We're going to start by constructing a tangent to a given point on a circle. So we're going to draw a tangent through point P on this circle. To do that, we draw a line connecting the centre and point P. Now remember, the tangent at point P is perpendicular to the line joining the centre to the point P. What we can do is pick a point anywhere, say around here. Next, put the compass point at P, extend the compass to this point here. Note the point of intersection of this circle with the line, and bisect the line segment joining these 2 points. I'll get the perpendicular bisector of this line segment, which is the diameter of this small circle. So, how do we get the perpendicular bisector of this line segment? Well, I've covered that in a previous video. We put the compass point here and open up a circle whose radius is more than half the length of this line segment, say about here. Next, with the same setting on the compass, we draw a second circle centered at the other endpoint, and we note the points of intersection of these 2 circles. Finally, we draw a line connecting these 2 points, and this line will be the perpendicular bisector of the line joining the centres of these 2 circles. Well, we're not interested in the fact that it bisects this line segment joining the centres of these 2 circles. We're interested in the fact that this line is perpendicular to the line joining the centres of the circles. So it's perpendicular to the line joining the centre of the big circle and point P, and that's what we want. So we're using the property that a tangent is perpendicular to the line from the centre to the point of contact of the tangent. Now, suppose point P is outside the circle and we want to draw tangent lines passing through P to this circle. There will be 2 of them. One of them will touch the circle up here somewhere and the other one will touch the circle down here. First, we draw a line from the centre of the circle to P. Next, we bisect this line. So again, we're not using any measurements, we're just using a straight edge and a compass. Now, to bisect a line, we mark off an arc whose radius is more than half the length of the segment CP. So we've done this before. Next, we step off the radius of this circle and draw another circle centered at the other endpoint, centered at P, and we note the intersections of the 2 circles. Finally, we draw in the perpendicular bisector. Now, we're not interested in the perpendicular bisector, we're interested in just the midpoint of this line. That's the point of intersection of the perpendicular bisector and the line joining the centres of these circles. So now we've got the midpoint. Next, we draw a circle centered at this point and whose radius is half the length of this line. We note the point of intersection of these 2 circles. This point here is the point of contact of the tangent from P to this circle. So here's the tangent. And the second tangent has its point of contact at this point here. Now, I'll call this tangent to the circle M, and the line from the centre of the circle to the point of contact is R. And of course, this line is a radius of the circle. Now, why does this construction work? Well, this angle up here is an angle in a semicircle. This dotted semicircle here. And we know from a previous result that this angle is 90 degrees. So we're just looking at the dotted semicircle. CP is the diameter of the dotted circle. Now, since M is a line that cuts this circle here, and Since R is a line that's perpendicular to M, and R is the radius of the circle, we know that M must be a tangent to a circle, because a tangent is perpendicular to the line joining the centre of the circle to the point of contact of the tangent to the circle.